Because so in yesterday's class, we have seen what are sets, how to represent sets, and we have seen some type of sets. So in today's class, we'll see some more types of sets and the Venn diagram. So we'll start first with the subsets. What are subsets? Let us say I have two sets. Let us take one set as set A. Let us say set A is like this. A is equal to, let us say it has elements 1, 2, 3. I have another set B. It has elements 1, 3, 2, 4, 5. Now, if we just analyze their elements, we see that we can see that the elements in A, they are also elements in B. 1, it is also contained in B. 2, it is also contained in B. 3, it's also contained in B. So every element of A is also contained in set B. So we can say that every element of A is also present in set B. Then in this case, we say that then A is subset, right? Like this, subset of B. That's A is subset means contained. So we can say that then A is subset of B. That's A is contained in B. So this is a definition of subset. So if we have a set, if it's all elements are present in any other set, we say that then this set is its subset. Now we'll check whether B is also subset of A or not. B is subset of A or not. If we check, we see 4 and 5. In set B, there are elements 4 and 5 that are not present in A. So I can say that B is not subset of A. Whether A is subset of B, but B is not subset of A. So in this case, we'll say that then A is proper subset and B is known as superset. So if A is only subset of B and B is not subset of A, in that case, we say that A is proper subset. Proper subset. While we called B in this case superset. Superset. So if we have a set A, if it is subset of B and B is not subset of A, then in that case we say A is a proper subset, B is known as superset. Now what happens when A is subset of B and B is subset of A? Let us see that. Let us say I have set A as like this. Let us say I have set A. A has, let us say, elements 1, 2, 3, while the set B has elements, let us say 3, 1, and 2. We can easily see that A is subset of B because every element of A is present in B. We can also see that B is also subset of A. B is also subset of A. So if we see that 3 is also present in A, 1 is also present in A, 2 is also present in A. So we can say that B is subset of A. And in that case, we see A has elements 1, 2, 3, B has same 1, 2, 3. So if A is subset B and B is also subset A, in that case, we can always see that A will be always equal to B. So there's a relation between these two sets. So if A is subset B, B is subset A, then we can say that then these two sets will be equal. So this was about the subsets. Now if we mathematically have to show A subset B, so we'll write like this. For example, if set A is subset of B, then we'll write mathematically like this. I will say for all X elements that are in A, if they belong to A, it implies that the X will also belong to B if A is subset of B. So if A is subset of B, then the X that belongs to A, it implies that that X also belongs to B also because it is subset. So the X that is present in A, it will be also present in B. So we say if X belongs to A, it implies then X belongs to B also because A is subset of B. Now what about this above relation? We can write like this. we can say that if x belongs to A, if x belongs to A, it implies if and only if x belongs to B. So we can say that in that case we have A equal to B. So if A is subset B, B is subset A, we write like this. If x belongs to A, if and only if x belongs to B. It means that if x is an element of A, that x will be also element of B. In reverse, if x is element of B, then x will be also element of A. So we'll have in this condition A equal to B. Now we'll see some more properties of subsets. First thing, phi, or we say that the empty set. Phi is considered, phi is the, by convention, phi is the phi or empty set. Phi, or that we also know as empty set, it is the subset of every set. It is subset of every set. Second thing, every set is subset of itself. Every set is subset of itself. So these are the two property, another two properties of subsets. That phi is the, by convention, phi or empty set, it is a subset of every set. Second, every set is the subset of itself. And after subsets, now we'll go for some properties of subsets in number system. Let us say n is a natural numbers, set of natural numbers, z is set of integers, r is, q is set of integers, while r is set of all real numbers. If we see that natural numbers, they are a subset of integers, while the integers, they are subset of rational numbers, while all rational numbers, they are a subset of real numbers. So this is a kind of relation that is followed by these number systems. Now let's move to the next part, that what about the real numbers? What are about the subsets of real numbers? How we represent the subsets of real numbers? Now subsets of, next topic, subsets of real numbers. Real numbers, that's are this one, subsets of real numbers. The subsets of real numbers are known as intervals. Intervals. And intervals are of three types: open interval, closed interval, semi-open or semi-closed interval. Let us see them one by one. First, let us see the first one, open interval. Open interval. Open interval is represented by a comma b, where a, b are any two numbers, and where a is less than b. And we just mathematically write like this: a comma b. It implies, it is equal to, it says it's the, it's a set of all real numbers x such that x is greater than a, less than b. So this open interval AB, it implies a set of all real numbers x set where x is greater than a, less than b. If we graphically see it, graphically it is like this. Let us say it's a number line. Let us say this is the number line. Let us say it is a and it is b. So graphically we show it like this. We use open circles. It means a and b are not included in the set. So right like this, it represents x, all real numbers x that are greater than a, less than b. So this is a representation of open interval. So it's a one kind of one kind of subset of real numbers. If we let us see some practical examples. Let us say I take open interval 1, 5, 2, comma 7, minus 1, comma 9. Similarly, minus 3.5, comma 6.4, and so on. So these are the examples of open intervals. Now let us see second type of subset of real numbers that are known as closed intervals. Closed interval. Second, that is closed interval. Closed interval. Closed interval. The closed interval is represented like this. The closed interval is represented like this. Square bracket a comma b square bracket. So it implies square bracket a comma b square bracket. It represents a set of all real numbers x such that x is greater than equal to a less or equal to b. We take a and b both. So if we show it graphically, let us say it is a here, b is here. So we use here closed circle, here also closed circle or dot circle, and then join them. So we'll get x greater than equal to a less or equal to b. Let us take some examples. Let us say I take example 3 comma 6. Let us say minus 9.5 comma 6.98, so on. So these are all some examples of closed intervals. And let us see the third type of subset of real numbers that are known as semi-open or semi-closed intervals. Third type that is known as semi-open or semi-closed interval. If we have at from one side open, another side closed, we call that semi-open or semi-closed, like this. Either this square bracket a comma b open bracket, or open bracket a comma b square bracket. So it says x, it represents a set of all real numbers x that are greater than equal to a less than b. It represents a set of all real numbers x such that x is greater than a less or equal to b. Let's take some examples of it. If we see some examples from it, we have examples like this. We'll take just two examples. Let us take 2 comma 5 minus 9 comma 6.9. Let us take two examples from it. Open bracket 3 comma 4.5 square bracket, open bracket minus 6 comma 6 comma 17 by 9, and then square bracket. So on. Similarly, we can represent infinite number of intervals or subsets of real numbers. So in this way, we can say that the intervals represent the subsets of real numbers, and they can be of three types. Now let's move to the next part. That is now the power set. Another type of set that is known as power set. I take a set. Let us say A, set A. Let us say it has two elements, 1 comma 2. Let us find all the subsets of the set. If I want to find the subsets, I know first empty set is the set is the subset of all set. Second, A itself, it will be the set's subset of itself because every set is subset of itself. Now we will find some proper subsets. Apart from these two, there will be all subsets, they will be proper subsets. From them, it will be 1 and we have 2. And there will be no any other subset of this of the elements of this set. So these are the total subsets that we can form from this set. They are 4. 1, 5, because 5 is subset every set. Second, A itself. Third, there, and after that, two proper subsets, 1 and 2. And there cannot be any other subset of this set. Now, if we see that, now we got the 4 subsets of this set. These are the 4 subsets. Now, if we make the set of all these subsets, 1, 2, 3, and 4, if we make them set, in that set, if we make them as elements in that set, these are the elements of that set. We called that new set as power set. It is represented by P, capital P of A, power set of A. It is equal to set of all the subsets of this set. It is first subset was 5, it will be first element in this set. Second element will be 1, comma 2. Third will be 1. Fourth will be 2. So in this power set is a new set in which every subset represents element of this set. So these are the 4 elements. Individually they are subsets, but when we make a power set, in the power set, these represent now the elements of this power set. So these are the 4 elements of this power set. And we'll see second thing. In A, we have 2 elements. In power set of A, we have 4 elements. Now, if we see, if we just take 2 square, it is equal to 4. So we are this 2, square 2, it represents number of elements in A. Similarly, it means that if we have any set, if we have any set A, if it is number of elements of A, let us say it is equal to M, then the number of elements in power set of A, it will be equal to 2 raised to power M, in which 2 elements, 5 and the set A itself, they will not be proper. Apart from that, 2 raised power M minus 2. These subsets, these total number of subsets will be proper subsets. It will be proper subsets. Total subsets will be 2 raised power M, in which phi and A itself, they will not be proper. And apart from them, 2 raised power M minus 2 subsets, they will be all proper subsets. So this was about power set. And now let's move to new uh, new type of set that is known as universal set. Universal set. If you have any set, let us say I take set U. U is equal to, let us say it in set U, let us say it has the first 10 elements of natural numbers. That is 1, 2, 3, 4, up to 10. Let us take its 3 subsets. Let us say I take A is equal to 1, 2, 3. Set B is equal to 4, 5, 6. Set C is equal to 2, 3, 5, 9. Set D is equal to 1, 9, 10. Now, if we see all these four sets A, B, C, D, if I see A, I can see that A is subset of U. If I see B, B is subset of U. If I see C, C is subset of U. If I see D, D is subset of U. I can see that all these sets are subsets of the same set. So if we have any one set and we have more more than one sets, if more than one sets are all subsets of this same set, we call them this set as universal set, and they are all its subsets. So if a set has more than one subsets, then we call that set as universal set, and they will call there as, then all those sets will be there its subsets, and while that set is known as universal set. So here U is universal set, while A, B, C, D are its subsets. If we take any other practical example of this set, if we have then, let us say, take set of all natural numbers. The set of all natural numbers, it will be universal set, while all set of all even natural numbers, even natural and odd natural numbers, they will be both its subsets. So natural number set will be, set of all natural numbers will be universal set, while these two odd natural numbers and even natural numbers, they will be its two subsets. Now let's move to the next part, that's a Venn diagram. Let's see what is a Venn diagram. Venn diagram. Venn diagram is nothing, it is the geometrical representation of sets and their subsets. In this diagram, what we do, we represent a universal set by rectangle. Universal set, we represent universal set by a rectangle. It represents universal set, and every subset of this universal set, that is represented by circle. For example, I have a universal set of all natural numbers. So I will represent it with square, with rectangle. It will be set of all natural numbers. I take its two subsets. Let us say set of even numbers, set of odd numbers, A and B. I know between set of even natural numbers and set of odd natural numbers, there is no element common. So I will just keep them separated. It means that, so I will write like this. I will show you like this. So it will be set of all natural numbers while it has two compartments, A and B, because the total elements A and B, they just comprise whole natural numbers. Here A represents set of even natural number, B represents set of odd natural numbers, and their total combination A and B, they represent set of all natural numbers, while they have no element common between them. So in general, if we take any universal set, in general we take any universal set, we represent it with a rectangle, and we represent its subsets by circles. If two subsets are apart, they don't have any region common, we say that they have no elements common between them. They have no elements common between them. Now, if in universal set we have two subsets but they have some region common, it means that some elements are common between them. Now, if you have like this, in this case, there's a 1 and in between there is second. I can say that, let us say it is A, it is B. I can say that then B is subset of A, because then every element of B is also every element of A. So I hope you have will have got all these concepts. So they are very easy concepts because they are the starting concepts, and in the next class we'll now see the application of Venn diagrams we'll see the operations of sets, and we'll see also the application of Venn diagrams in the operation of sets, and also the complement of set. In this way, this topic is complete, and then we'll do the questions. So that was for today.